Welcome to clickmyproject.com. Let us discuss about a novel clustering-based spectrum sensing in cognitive radio wireless sensor networks. Let us discuss about the abstract of the product. So, the wireless sensor and active sensor networks are spatially distributed autonomous sensors to monitor physical or environment conditions. So, a sensor node might vary in size from that of showbox node to the lest all the functioning modes of genuine microscopic dimension have yet to be created. So size and cost of the sensor node results in corresponding constraints on source memory such as energy, memory, computational speed, and communication bandwidth. So in this proposed work, an energy efficient spectrum handoff scheme is developed for an sensor network assisted cognitive radio network. So the secondary uses or energy constraint nodes with an energy harvesting capability from the environment. So when actual sensing process, select the node from active subset, and while performing the scheduling process, switched. So the active subset to sleep mode. So the sensor nodes are performing sensing process based on the respective time duration. So here we using the primary user activity, only few number of sensors are switched to active subset to sleep mode during the respective time slots. Let us discuss about the flow diagram of the process. So this is the overall flow diagram. In this process, nodes and base station deployment. First of all, we fix the nodes and base station of the deployment, and then by using the JCR algorithm. So JCR algorithm is a joint subcarrier routing algorithm, and then by using this algorithm, we selecting the cluster head selection and then routing path design. So routing path design is calculated by head to the nodes and to the base station. So only to the unbalanced cluster head selection achieve the maximum network lifetime. So we calculating the performance analysis of the process. So the JCR algorithm is used for to calculating the cluster head selection, whatever may be it will be choosing the cluster heads and the nodes of the base station. So the routing path, it will be connected to the cluster head and the nodes of the path, so lead to the unbalanced cluster head selection. In case if in case we select the unbalanced cluster head to achieve the maximum network lifetime. First of all, we have a proposed work is to achieve the maximum network lifetime. So only we calculating the lead unbalanced cluster head selection and then calculating the routing path design of the process. So the JCR algorithm, it must be used to cluster formation. So finally calculating the process of the algorithm. So that is will be equaling to. So in the cluster formation, in this proposed work, higher performance sensor nodes are deployed for the scope of area monitoring. So low performance of sensor nodes are deployed at the rest of the monitoring area. So at last, base station is deployed at the center of the monitoring area. So there are three areas. One is low performance, high performance, and the center of the monitoring area. So in order to perform the target tracking coverage, monitoring area is divided into several small areas. So in each small area having a few number of sensor nodes. So these sensor nodes are formed as a clusters and cluster head node. So cluster head node, it will be selected the maximum energy efficient node and the node energy and the signal strength of the process. So these are the procedure to calculating the sensor node on the cluster head of the process. And the next cluster process is cluster updating. So basically cognitive radio does not change their location during the time duration of cluster updating. Process is performed when the number of registered nodes are changed. So the location of the cognitive radio is changed. So if the nodes receive the ADV messages from new CR, it will change the cluster group only in the distance. The old CR is greater than the distance of the new CR. So the old CR deregistered the nodes once it received the L request message from a cluster node. Finally updates its cluster and nodes field ADV messages, it will be returned. So these are the process of the cluster updating. Finally, we achieve the maximum network lifetime. Otherwise, the process will be routined the JCR algorithm and the performance analysis will be calculated. So the estimation of end-to-end delay, consume energy, and mean square error, and probability and reductionness will be estimated. So these are the overall flow diagram of the process. Let us discuss about the running procedure for the product. So click the main file and then run. So it's take time to display. In this first figure, the sensor node deployment. So here the sensor nodes are randomly deployed by using the area up to 100. So this is also 100. So the nodes are deploying randomly. Each and every section, it should be placed in different position. So this is the figure of explanation of sensor node deployment. And then, so in the previous figure, there is a cluster sensor node deployment. In the cluster formation, here we using the formation of cluster. So that is a group of clusters. So this pink color denote the one type of group of cluster, and the green color denote the one type of group of clusters. So on the red will be dictated cluster heads. So each and every cluster formation, here we using the cluster head of the process. So on the yellow color, it's one type of a cluster formation. So these are the various types of a cluster formation in the particular area of the process. So in the next figure, cluster it should be updating. So cluster it should be updating in all the variants. So here we using the clusters are update in every iteration. So here we using the cluster because of the cluster updating, the values of particular sensor nodes are deployed. So because the yellow nodes indicating the cluster updating, and actually the black incident cluster updating, so different process will be updated in different various of the sustain. So these are the cluster updating process in this figure. So in this figure, the comparison between the random update method and the reclustering scheme. So the two types of methods will be compared. One is random update. Here we using the randomly updated what type of residual time energy will be increased. But reclustering concept, we using the residual time of energy will be decreased. So here the x-axis undergoing the time label, and the y-axis undergoing the total residual energy. So total energy and residual must be increasing randomly updated the process. So the comparison between the random update method and reclustering scheme is processing to achieve the more comparison between the random update and the reclustering of the process. So in this figure, a comparison of network lifetime, ECRU and DDCD and leach. So DDCD and leach is an existing method, and ECRU is our proposed method. So here we are using the alive nodes of numbers. What type of algorithm we use? How many nodes are alive in the presence? So here we are using the ECRU is the highest alive nodes are present in the time label, and particular node we will compare with the DDCD and leach algorithm of the different network lifetime of the process. So this is the comparison graph between our proposed and existing method. So network residual energy distribution of statistical histogram technique. So number of nodes, how many number of nodes are presented, and then distribution energy residual of the percentage in indicated with percentage. So compared to the existing method, our proposed rate should be high. And then the next figure, this is all the comparison graph, a network residual energy distribution statistical histogram. So percentage of the sampling time and reduction ratio of sensitive data. So compared to our existing method, the percentage should be high. So compare all this figure. So this is it, the both are same. So here we are using the three techniques, and the percentage of sampling time reduction in sensitive data, it should be high or low. So these are the comparison graph of the process. So here in this figure, sensing time on each channel. So particular channel, how will be derived for the each channel assumption. So the red is one type of a channel, and green is so indicate one type of a channel, and blue is indicate one type of a. So number of iteration is presented. How many sensing channel is presented in the particular region of the process. So in the next figure, so this is a trace on estimation of the performance over time. So how will be it should be traced, and the average trace will be calculated. So mean error coefficients of the covariance of the concept, so the estimation of the performance, the overall time. So these are overall running procedure of the process. Thank you for listening this video.